In this video, you'll learn how to fully automate your Confluence Cloud backups so they run on a schedule, are stored safely in the cloud, and alert you when anything goes wrong. This is the second video in a series about recovering data in Atlassian Cloud. In the first video, we learned how to fully automate your Jira Cloud backups. So if you saw that video, much of this video is going to look the same and you'll be able to follow along more quickly. Okay, let's get started. The first step is to look at how manual backups work in Confluence so that we know what we're automating and how to troubleshoot it. To do a manual backup, we're going to go into Confluence and go to Settings, scroll down in your left-hand navigation and find Data Management and go to the Backup Manager. To do a backup for a Confluence Cloud, you're going to go down to the section called Restoring a Confluence Cloud Backup. And there's two steps to generating a Confluence backup, just as there was in Jira. The first step is to use this button to create a backup file of your data that is stored in Atlassian's Cloud. And then the second step is to download that data once it is available. Before you generate the backup file, you'll see there is a checkbox to select whether or not to include attachments. This checkbox is important because it not only controls the scope of your backup, but it also controls how frequently you can generate a backup file. Atlassian only allows you to create backups that include attachments once every 48 hours. So if you deselect this option, you'll be able to generate your backups more quickly. So if you want to automate your backups to run more frequently than once every 48 hours, you're going to need to design an automation strategy that includes a mixture of backups that do not have attachments, which can run daily or more frequently, and a backup that does include attachments, which cannot run more than once every 2 days. So to create this backup file, we'll just press Create Backup for Cloud. It's going to process and generate my backup. And once the backup is complete, you'll see it's available for download as a zip file. You can just press this button and it will download your zip where you can store it someplace safe. You'll also notice that these files are available for 14 days. So that means you can return to this screen anytime you want to download your most recent backup file, as long as that backup is no more than 14 days old. All right, so this was the manual process where you generate your backup file in Atlassian Cloud, and then you download that backup file so you can store it someplace safe. And now let's go to AWS where we can automate these steps. To automate your backups in AWS, the first thing you need to do is go to AWS Secrets Manager and create a secret where you can store your Atlassian API credentials. I already completed this step in the first video of the series, and because the same credentials work inside Jira and Confluence, I don't need to create a new secret. In the last video, we created the secret named Atlassian Cloud Backups, and this secret has two key value pairs. The first key is for email, and it will store the Atlassian email address of the account that you want to use to create the backups. And the second key is for an API token associated with that email account. If you want to see the exact steps for creating this secret and generating an API token, go to the first video in the series where I created this key value pair, and you'll see the exact steps needed. After you create your secret in Secrets Manager, the next thing to do is go to S3 to create a bucket for storing your backup files. You'll notice that in the last video, we created a bucket for our Jira Cloud backups, and now we're going to create a new bucket for storing our Confluence Cloud backups. We could store them in the same bucket, and in many organizations that might work just fine, but you want to create a separate bucket for your Confluence data if you want to be able to more easily control access to your Jira data backups independently from your Confluence data backups. So let's go to Create Bucket. We're going to create a general purpose bucket and give it a bucket name. Again, you're going to want to prefix your bucket name with a unique identifier such as your organization name, because S3 buckets require globally unique names. Here's my bucket name, and I will leave the remainder of these configuration settings at their default, including having versioning disabled. And we'll create the bucket. Okay, now we have two separate buckets for our Jira Cloud and our Confluence Cloud backups. Let's go into our new bucket for Confluence Cloud. And what we want to do now is create a retention policy for our data so the bucket doesn't get too large. So we'll go to Management and create a lifecycle rule. We'll give it a name. We're going to apply this rule to all objects in the bucket. And we're going to expire the current versions and set them to expire after 31 days. The reason we are setting this to expire after 31 days is because Atlassian does not support restoring cloud backups after 30 days. So there's really no reason to retain your backups longer than that unless you want to be extremely risk adverse. But in this situation, I'm going to enforce the 31-day policy so that I have at least 30 days of backups in alignment with what Atlassian will support restoring. And now I can create my rule. And we've created a bucket to store our backups with a retention policy that will delete the objects once they are too old to be restored. Once you have your API credentials stored in a secret and you have a bucket available for storing your backup files, next thing to do is go to AWS Lambda, where you can create scripts to trigger the 2 steps of the backup process. These are the scripts that we created in the last video, where we have one script to trigger the backup, that is trigger the creation of the backup on Atlassian server, and then the second script downloads that backup file once it's available and stores it in S3. You want to create 2 separate scripts because Lambda functions have a maximum timeout value of 15 minutes, and 15 minutes is usually not nearly enough time to both trigger a backup, wait for it to be created, and then download it and upload it. And so it's very difficult to trigger both of these operations from the same script. You want to have the 2 scripts independent and run on synchronized schedules. So to create these same two scripts for Confluence, we'll go to create function, author from scratch, give it a name. The first one will be our trigger script that triggers the creation of the backup file on Atlassian server. And we are going to have it run in Python, and we will create our function. Once your function is created, you'll scroll down to the code tab, and this is where you can create your Python script that will use Confluence's API to trigger the backup creation. To make this easy, you can go to upload from zip file, where you can upload a zip file that contains all the code and modules as a ready-made package. In the video description, I'll share a link to a Git repository where you can download these packages and use them for yourself. We'll save this. So this is a pre-configured Python package with the Python script and all of the dependent modules, so it is ready to run, but there is some information that this script needs to be able to run successfully. It needs to know the name of the Confluence site that it's going to back up, and it needs to know where to find those API credentials that we stored inside Secret Manager. So to do this, we're going to configure environment variables. And I will create the 3 environment variables that we saw listed in the code header. Okay, I've just created my 3 environment variables. I have my site name, which is the name of my Confluence site, including the Atlassian.net portion. I have the name of the secret that I created in Secret Manager. And I have the region, the AWS region that secret is created in, which for me is US West 2. I will save this. And now we need to update a few of the script configurations before we can test it. The first configuration we want to update is the timeout value. This script will usually run in 3 seconds because it's just a single API call, but that's still a little bit short. So we're going to edit our timeout value first and set this for 1 minute, which is plenty of time to make that API call. And the second thing we want to configure is our permissions. So we'll come into the permission tab. This is an AWS role that Lambda created for us automatically for the script. We're going to open this in a new tab. And we need to add permissions to this role so that it can access the Secret Manager. To do that, we'll go to Add Permissions, Create Inline Policy. We'll select a service, which is going to be Secrets Manager. We need to grant read permission, which is get secret value. And we want to limit this to the single secret that we created for our API credentials. So we'll go to add ARNs and paste the ARN of our specific secret. And we'll add this. Press next. Give this a name and create policy. With our policy configured, we can now go back to our Lambda function and press the test button. It's going to ask us to create a test event, and we will leave this as the default hello world test event because we do not need to pass variables. Press save, and now we can test our script. It was successful, and if we go back to Confluence Backup Manager and refresh our screen, we can see there is a backup in progress that was triggered from our script, so we know this is working correctly. After you test your script and know that it is working correctly, the next thing to do is to create a trigger so that it runs on a schedule. So we'll go to Add Trigger, and we'll use EventBridge, and we'll create a new rule. Give it a name, and we'll configure this trigger with a cron expression, and this expression tells EventBridge to run our function every day, Monday through Saturday at 10 a.m. UTC. The reason why we are running this Monday through Saturday is so that we can run a regular backup 6 days a week, and we will run a full backup with attachments 1 day a week. You might remember that Atlassian only allows you to create a full backup with attachments once every 48 hours. So to keep my automation simple, I'll run the full backup once a week. You can run yours more frequently than that. But in my setup, I have regular backups Monday through Saturday, and next we'll configure a full backup to run on Sundays. So I'm going to add this, and let's create our second trigger to run on Sundays. Add trigger, use EventBridge again, create a new rule. Once again, we'll use a cron expression. This cron expression is similar to the last one, except that it will run every Sunday instead of every day, Monday through Saturday. Let's press add. There's one more thing we need to do for this last event trigger, and that is configure it with a parameter that will tell our Python script to include attachments in the backup file. So we'll go into our weekly backup trigger event. We'll select targets and edit our target. And under configure target input, we'll select JSON, and we will give it a JSON parameter. And by including this parameter, include attachments true, this tells our script to set that flag to tell that has Confluence include attachments in our backup file. Without this parameter, the script will exclude attachments by default so that it can run as many times as we want to. We'll press next, and next, and update rule. Okay, we have fully configured our trigger script. Now we need to create our download script that will download that zip file once it is ready and store it in S3. So we'll go to create function, give it a name. This will use Python. And we'll leave everything else at the default. Create function. Once your function is created, just like before, we'll go down to the code section and upload our code from a zip file. Once again, in the video description, you'll find a link to the Git repository where you can download these scripts for yourself. So now we have our pre-written Python script pre-packaged with its dependent modules. And now let's configure this script so it has everything that it needs to run successfully. Just like before, we need to go to environment variables to configure the necessary environment variables. And it will use the same 3 variables as before, plus one more to reference the S3 bucket name where it needs to store the backup file. We'll go to an add environment variables, and we will configure our 4 environment variables. Okay, here are my 4 environment variables. The site name where we want to download our backup from, including the Atlassian.net portion, the name of our AWS secret, the region of our AWS secret, and our new variable, the name of the S3 bucket that we created to store our files. We'll save these. We also need to update the same configurations we updated previously. So we'll go to configuration, and we will need to edit our timeout value. Last time we edited our timeout to be 1 minute. This time we're going to use the maximum timeout value, which is 15 minutes, because we need to ensure that our Lambda function has plenty of time to download this zip file. 15 minutes should be plenty of time in most cases for an AWS connection to download a zip. We'll go to save, and we also need to update our permissions. Just like before, AWS created a new role specifically for this Lambda function, so we can create an inline policy for this role. So we'll go to create inline policy. First, we need to grant access to our secret manager. Give read access, get secret value. And we will limit this to the specific secret that stores our API credentials. Go to add ARNs, paste our ARN value, press add. We need to add one more permission for S3. We need to give write access, which is put object. And we need to grant access to our specific S3 bucket. Go to add ARNs. Enter our bucket name, allow any object name, and place our ARN. Go add. Now we can press next, give this a name, and create our policy. Back in AWS Lambda, we should be able to test our policy now. So we're going to press test, create a new test event, use the default hello world template, give it a name and press save, and run our test. It's now downloading the file. It's successful. And if we jump over to S3 and refresh our bucket, we'll see that we did successfully download our backup file from Confluence Cloud and store it safely in S3. And now the last thing to do to configure this script is add a trigger so that it runs on a schedule. Go to add trigger. We'll use EventBridge again. Create a new rule. Give it a name, and we'll give this a cron expression. And this expression is very similar to the last one, except that it will run at 11 a.m. UTC instead of 10 a.m. UTC, and it will run every single day. So the important parts here is that this expression is configured to run 1 hour after our trigger functions run. This gives Confluence a full hour to generate the backup file before this script runs and tries to download it. And in my environment, 1 hour is plenty of time for that backup file to become available. In your environment, if it takes more time, just space out these triggers so that your download trigger doesn't execute until you're confident the backup will be ready. The other difference is this is configured to run every single day of the week, and that is because we do not need to distinguish between backups that have attachments and do not have attachments when we download them. It's all the same, so we can use the same download operation to support both kinds of backups as long as you have your trigger spaced out that it's enough time for the attachments backup to be ready also. Let's go to add. And now both of our Lambda functions are configured and ready to run every single week. And if you followed along with both tutorials, you'll now have 4 functions, 2 of them to control Jira backups and 2 of them to control Confluence backups. The last thing to do to finish our fully automated backup system is to configure alarms that will alert us via email anytime one of our backups fail. You can see that I have the 2 alarms that we created for our Jira backups in the last video, and we'll create the same 2 alarms to support Confluence. Let's go to Create Alarm, select Metric, go to Lambda, Resource, and first we will find the errors metric for our Confluence backup trigger. That's right here. This is the first function that will run for Confluence. Select our metric. We'll select the maximum statistic, and we will trigger this alarm anytime it is greater than or equal to 1. That means if we have at least 1 error within a 5-minute period, this alarm will trigger. Next, we need to create a subscription topic so that AWS can send an email to subscribers when this alarm triggers. If you followed along in the last tutorial, you could use the existing topic that you created for Jira, unless you need different people to know about a Confluence backup failure versus a Jira backup failure. We'll give this a topic name and enter our email address. Press Create Topic. Next. Give this a name and press Next. And create alarm. After you create that new subscription for your alarm, AWS is going to send you a subscription confirmation. So make sure you click into this and confirm your subscription before testing your alarm. To test our alarm, we can go back to our Lambda function. So this is the Lambda function for our Confluence backup trigger, the first script, and we can temporarily modify our script to force an error. Deploy your changes. Now we can test this again, and we should receive an authentication error now. Here's our error. Gave us a 403 instead of a 401. That's okay. After several minutes, AWS should detect the failure in the Lambda function and send you one of these error emails. This email won't tell you exactly what went wrong. You can see we don't know that there was an authentication error or that 403 error, but we know our backup failed, and so we can now go into the CloudWatch log files and troubleshoot the specific error. So the point is, your backups will not fail silently. You can let them run, and if they ever break, you will receive one of these emails. After you test your alarm, make sure you go back in and restore your code. Redeploy it, make sure it's working again. It works. And now we can create an alarm for the second function. Okay, back in CloudWatch, we have one more alarm to create. Go to Create Alarm, select Metric, Lambda, Resource. This time we'll select the errors for our download function, which is the second script that runs. And the rest of the process will be the same. On the screen for configuring your notifications, you'll select an existing SNS topic because you very likely will want the same people to receive notifications for both sets of failures. Go to Next, give it a name, Next, create your alarm. And to test the second alarm, you'll do it the same way as the first one. Go into Lambda, change your code temporarily, force an error condition, verify you received an email, and then change your code back to make sure everything is working correctly. And that's it. Now you have a fully automated backup system for your Confluence site that will run on a schedule, store your backup files safely in the cloud, and send you an email anytime something breaks. I hope you're finding this series helpful, and in the next 2 videos, we'll learn how to restore our Jira and Confluence backups to recover from a data loss. In the meantime, check out my website at www.agile-innovations.tech to keep learning about using Jira in a regulated space. Thanks for watching. See you next time.